Hey, this is Santiago.
And this is Austin.
We're here to talk to you about electron configuration and its applications with the atom. Here's the electron configuration of aluminum, and what we're going to do is going to break it down. So here's the electron configuration of aluminum. In electron configuration, there are different sublevels. These four sublevels are S, P, D, and F. The S sublevel holds 2 electrons, the P sublevel holds 6 electrons, the D sublevel holds 10 electrons, and the F sublevel holds 14 electrons. In the electron configuration of aluminum, you can see the different sublevels. As you can see, the exponent, or the number above the sublevel, indicates how many electrons are currently in that sublevel. If you notice on the last sublevel, there's only 1 electron, but P can hold 6 electrons. That tells you that there is 5 unpaired electrons.
Writing an electron configuration is very simple, especially if you keep a few things in mind. In order to make this process really simple, you want to have a periodic table that looks like this. Now, where are the SP and D, SP, D, and F blocks? Blue element in this periodic table is S,
When you look towards the right and see the yellow elements, that is the P block.
and the pink elements are the D.
The green elements are in the F block.
Now, you get the coefficient of the sublevel by looking at the period number. For instance, for the S and P block, you would simply look at the period number. However, the D and F block are a little bit different. As you can see, as I have written here, the 3. What I mean by this 3 here is that these elements right here, although they are on the 4th period, they are actually part of the 3D sublevel, and these elements are part of the 4D sublevel, and so on and so forth. F is even more different since it starts at 4F, even though it's on the 6th period. Now to start really explaining how to write electron configuration. Simply move along the period going from left to right, starting at hydrogen until you reach the element. If you do not, then you simply move down a period, and again, starting at the left, move from left to right until you reach your element. While doing so, you want to write the appropriate sublevels, coefficients, and subscripts until you reach the element that you're writing the electron configuration for. So let's take, for instance, aluminum, as we've used previously. We'll start at hydrogen and work our way down. So we pass the 1s sublevel, so we'll write 1s2 since that sublevel will be filled. Then we move down to the 2s2. Then we move down to the 2s sublevel, and again write 2s2 since this sublevel will be filled. And then we write the 2p6 for the same reason. Then we'll write 3s2, and then finally 3p1. To write the subscript for the last sublevel, you'll basically take the position of the element in that block. So, since aluminum is the first element of the 6, I'll write a 1. Otherwise, say if I was writing an electron configuration for chlorine Cl, I would write 3p5 since it is the 5th of the 6 elements in the 3p sublevel. So, for further clarification, just go over a few more examples. So, to a really simple example will be using hydrogen. So, since this is the 1s sublevel, I'll write 1s and then its position in this sublevel 1. So I would simply write 1s1. An electron configuration for Cu would be 1s2, 2s2, 2s, 2p6, 3s2, 3p6, 4s2, and then 3d9. Now to move on to noble gas form. Noble gas form, you're basically simplifying the writing of electron configuration. In order to no, write the electron configuration in noble gas form, we simply take the noble gas that's closest to the element. So for this example, I will use aluminum again, and I'll take the one closest to it that isn't after, that's very important. So I'll take neon and then go from there. So I'll write neon in brackets, 3s2, and then 3p1. So it'll look like this. Really simple, right? And that just about concludes electron configuration.